we are going to discuss about the this one binding energy curve and then radioactivity. In the radioactivity or the binding energy curve, here we are having a graph. Here we are having a graph. Between the graph is drawn, okay, between the average binding energy and its atomic number. Its atomic number is it. Hello. Yes. See the in this binding energy curve with respect to entrance either in MSET or in BEDSAT or JEE Mains or NEET. Okay. Number they have been asked. For IPE, it is one of the most important 4-mark question. One of the most important 4-mark question for IPE. Okay. On the y-axis, okay, we are having the binding energy per nucleon. Binding energy per nucleon. And on x-axis, we are having the mass number. Okay, we are having the mass number A. Okay, suppose here up to maximum we'll have the maximum, it is 210. Okay, suppose uranium, okay, we can consider 235, okay, and thereafter it will be decreases. Firstly, from 0, I'll consider here it as 50, 100, or here it is 150, and here it is 200. From 0 to 50, I am considering initially. As the mass number increases, binding energy per nucleon will also be increases. That is, say, suppose let us consider lithium, okay, and then sodium, calcium, okay, and then zinc, okay. That is approximately up to the atomic number 30. Okay, you can see here what will happens, number of neutrons is equal to 4. Here 23 now. Number of neutrons is 12. That is 20. That is 30. That is almost the number of neutrons equal to number of electrons, or it will be plus or minus 1 or 2. Okay, in this case it is number of neutrons is equal to number of electrons plus 1. So as the mass number increases, binding energy will also be increases. Okay, due to this additional electron, lithium is having the additional electron. Okay, due to that, okay, what will happen? Binding energy per nucleon will be decreases. Okay, here it is helium. Okay, this is lithium. Okay, as that means whenever it is having like this 20 and 30 equal number, then the binding energy per nucleon increases. If you have like this, that is, if number of neutrons, if number of neutrons is equal to number of electrons or protons plus 1, then binding energy per nucleon decreases DCR. If it is equal, then it will be increases. So there will be an increase. Okay. Here we'll have carbon. Say carbon C612. Number of neutrons is 6. Okay. And the down again nitrogen, oxygen, fluorine. Okay. Like that. Like that up to there is an element called iron. Okay. Iron. Okay. For iron, okay, we are having a graph between on x-axis we are having mass number A, and on y-axis we are having that no screener.
Yes, sir.
Why? Why? See, if it, now it is visible.
No, sir.
No, sir.
కనిపిస్తుందా?
కనిపించట్లేదు సార్.
కనిపించట్లేదు.
No, sir.
రిపేర్గా ఉండండి. అమ్మా ఇప్పుడు కనిపిస్తుందా?
ఎస్ సార్.
Yes, sir.
Yeah. I think 1 minute. Now we are drawing the graph for binding energy per nucleon to the mass number. 8 is the mass number. Okay. Now initially we are having the mass number from 0 to 50, and then 100, 150, 200, 210. Why I consider 210, I will tell. Okay. For uranium, I know that it is 92U235. 92U235. Isotope of uranium, we are having that 92U238. Okay. So if the number of neutrons is equal to, if number of neutrons is equal to number of electrons, binding energy per nucleon, okay, will be increases. This is for helium. Whereas for lithium, it is number of neutrons equal to number of electrons plus 1. So due to additional 1 nucleon or 1 neutron, the binding energy will be decreases. That is, as A increases, the binding energy will be decreases. So it is for lithium. And for carbon, it will be increases. And for nitrogen, decreases. Okay, like this. Increases, decreases, increases, decreases. Okay, and at a, from here what will happens from the calcium onwards? What will happens? Here it is calcium. From calcium onwards, what will happens? Binding energy per nucleon increases and it reaches to a maximum value. It reaches to a maximum value. Suppose here it is iron. Iron is having a mass number 56. Thereafter, the binding energy per nucleon decreases. Okay, because the number of neutrons is equal to number of electrons plus 1. Okay, here we are having the some points or basic features in this graph. Okay, if at all if they ask, okay, they asked only on the for which element binding energy per mass number is maximum. Okay, binding energy per nucleon or average binding energy is maximum for iron. Okay, and it is having a mass number 56. Okay, keep the heading as variation of binding energy. Keep the heading as variation of binding energy variation of binding energy per nucleon with mass number. Okay, completed. Variation of binding energy per nucleon with mass number, that keep it as side heading and then draw the graph. ఎవరినా ఈ మిడిల్ క్లాస్ గేమర్ completed. Srihita, Gayatri, లేరా? Diagram completed?
Yes, sir.
Diagram completed. అందరిది అయిపోయిందా? All of you completed diagram? Next point, right on. The main features of binding energy curve are given below. Point wise write down. First point. The minimum value of binding energy. The minimum value of binding energy. You should write total. Don't write shortcuts. ఐపీ ఎగ్జామ్లో మీరు షార్ట్ కట్లు ఏం రాయకండి, టోటల్ రాయాలి. ద మినిమం వాల్యూ ఆఫ్ బైండింగ్ ఎనర్జీ పర్ న్యూక్లియాన్ is in the case deuteron 1.11 MeV. Okay. Completed. Next, second point. The maximum value of binding energy per nucleon. క్లాస్ అంటే ఇంట్రెస్ట్ లేనివాడు నీకెందుకురా క్లాసు? చదువు అంటే ఇంట్రెస్ట్ లేనప్పుడు ఇంకా కాసుకోవాల్సిన బర్రలే ఇక ఇంటర్మీడియట్ తర్వాత ఇక కనీసం బీపీఓలో అయినా కూడా కాల్ సెంటర్లో కూడా డిగ్రీ అడుగుతున్నారు. ఐబీఎంలో డిగ్రీ మెయిన్ చేస్తాడు, బిఏ బికమ్ నాట్ వ్యాలిడ్ అంటున్నాడు, ఓన్లీ బిఎస్సీ అంటున్నాడు. ఏ కార్పొరేట్ కంపెనీ చూసినా కూడా మినిమం డిగ్రీ కంపల్సరీ, మా బీటెక్ అయితే ఇంకా బెటర్ సార్ అంటున్నాడు. maximum value of binding energy per nucleon is 8.7 MeV for nucleus iron with atomic number 28, mass number 56, which is most stable. Okay, which is most stable. Next, binding energy is high in the range in the range 28 is less than A, less than 138, okay, is very close to 8.7 MeV. MeV. Okay. Further increase in mass number, then binding energy per nucleon decreases. Okay, binding energy per nucleon will be decreases. Okay, completed up to here. అయిపోయిందమ్మా 3 points.
Yes, sir.
Completed, sir.
నెక్స్ట్ 4 మీరు పాయింట్స్ ఈజీ గుర్తుపెట్టుకోవచ్చు. చూడండి, ఫస్ట్ ఏమో మినిమం వాల్యూ, సెకండ్ మ్యాక్సిమం వాల్యూ, థర్డ్ 28 to 138 వరకు మ్యాక్సిమం వాల్యూ 8.7 దగ్గరగా ఉంటుంది. ఆ తర్వాత డిక్రీజ్ అవుతుంది అని మీరు గుర్తుపెట్టుకోవడానికి కూడా ఈజీగా ఉంటుంది. ఓకే, మీ ఎన్సీఆర్టీ టెక్స్ట్ బుక్లో కానీ లేకపోతే ఏ మెటీరియల్లో అయినా కూడా మనకి 7 to 8 పాయింట్స్ ఉంటాయి. ఆ 8 పాయింట్స్ నుంచి 4 మార్క్స్లో డయాగ్రామ్ తీసి కనీసం మినిమం 5 పాయింట్స్ అనేది రాయాలి. ఎందుకంటే డయాగ్రామ్కి ఒక 1 మార్క్ వేసుకుంటారు. ఓకే, కనీసం ఒక 5 పాయింట్స్ అన్న రాస్తే మీకు వ్యాలిడ్, ఆ 4 మార్క్స్ అనేది వేయగలుగుతారు. దిద్దే వాళ్ళకు కూడా మనం అవకాశం ఇవ్వాలి. ఓకే, నేను 4 పాయింట్స్ రాశాను సార్ అంటే, ఓకే. నెక్స్ట్ న్యూక్లియై విత్ మాస్ నెంబర్ 40 less than or equal to A, less than 180. Okay, less than 180. Okay, less than 180. Then what will happens? The nuclei will be more stable or greater stability when A is greater than 220. The nuclei is distinctly unstable. That is single heavy nucleus breaks into two nearly equal nuclei. Okay. Next, fifth point. Light nuclei such as hydrogen atom combine to form heavy nucleus okay to form heavy nucleus okay as helium for greater stability ఈ ఫోర్త్ పాయింట్ ఫిఫ్త్ పాయింట్ మళ్ళీ మనకి న్యూక్లియర్ రియాక్షన్స్ లో వస్తాయి. న్యూక్లియర్ ఇదేమో ఫిజన్ అంటాం, FISS డివైడ్స్ ఇంటూ 2 స్మాల్ న్యూక్లియై. ఓకే, ఇదేంటి ఫ్యూజన్ అంటాం. Okay, completed. అయిపోయిందమ్మా?
Yes, sir.
Okay, fine. Next one. Okay, next one we'll go to radioactivity. Okay, radioactivity. In this radioactivity, we are having the first alpha decay and then beta decay. In this beta decay, we are having two types. That is beta positive and beta negative. Gamma decay means it is energy lost only. Okay, or there is an energy change. Gamma decay. Thereafter, okay, we'll study about the radioactive or decay law. In this decay law, we'll have decay constant, half-life, mean life, and then finally activity. Okay, one of the most important topic in any entrance exam or even in the this one IP exam. Okay, మీరు JEE మెయిన్స్ తీసుకోండి, ఎంసెట్ తీసుకోండి, బిట్సాట్ తీసుకోండి, లేదా ప్రైవేట్ ఇంజనీరింగ్ ఎంట్రన్స్ ఏ ఎగ్జామ్ SRM కానీ VIT కానీ ఓకే ఏ మణిపాల్ కానీ ఏ ఎంట్రన్స్ ఎగ్జామ్లో అయినా కూడా ఈ రేడియో యాక్టివిటీ మీద క్వశ్చన్ ఉంటుంది. ఓకే, ఆన్ దిస్ రేడియో యాక్టివిటీ వీఆర్ హ్యావింగ్ ఏ క్వశ్చన్. Okay, fine. Before going to see the alpha decay, beta decay, and this one, firstly, let us consider here I'm having a chamber. I'm having here a radioactive substance. Okay. Generally, this radioactive substance, it will be from the lanthanide or actinide, or whenever the nuclei is having a mass number greater than 56, then we will have the nature, this type of nature. So suppose let us consider uranium 92U235. That is, we are considering a heavy nucleus. In the heavy nucleus, what will happens? Okay, the electrons, okay, which are in the higher state. Okay, suppose if we consider this one copper or nickel, okay, that will be the maximum. It will be either in 3D or 4s. If we consider the mass number which is greater than 56, then it may goes to 5F or 6s. 5F or 6s. Okay. Okay, fine. Now here it is that the point of concentration it is whenever we supply the energy, electrons will go to the excited state. In that excited state, how much time it will stays? Suppose if I consider sodium atom, I supply energy, suppose 13.6 electron volt or 3.4 electron volt. So on so energy I give. Okay. With the supply of that energy, how much time the electron will be in the first excited state? That means depends upon the energy supplied. Okay. It depends upon the energy supplied. Up to that time, the electron will stay. Like that, whenever the neutron is in the higher state, then after some time, with the loss of energy, that neutron will comes to ground state, or with the supply of energy, the electron will comes to the ground state. With or without the supply of energy, the neutron will come to the ground state. Okay. So with the supply of energy, if the neutron is coming to ground state, it can be called as stimulated. Without the supply of energy, that can be called as spontaneous. See, for example, okay, why I will ask some of the students, okay, have you done this work? Have you done? See, I think yesterday also I asked some people about, have you completed photoelectric effect? Right? Did I ask or not? Did I ask or not? Okay. In that one, you can see that is whenever I ask, okay, at least not at that time, we can see the afterwards they may read. That is by giving the energy, at least after some time they may do. Okay. Okay, fine. Spontaneous, without I'm saying read this one. Some students they will read by themselves. That can be called spontaneous. In our life also, we are doing the stimulated process and spontaneous process. Okay. ఇప్పుడు సపోజ్ ఏదైనా రెస్టారెంట్ కానీ సినిమా కానీ క్రికెట్ కనుక్కోండి. ఓకే, మదర్ ఫాదర్ ఏం చెప్పరు, మనం స్పాంటేనియస్గా టైం చూసుకొని అమ్మ టైం వస్తుంది కదా అనుకుంటాం. అవునా ఉమర్? ఇండియా వర్సెస్ ఆస్ట్రేలియా టెస్ట్ క్రికెట్ ఎప్పుడుంది? థర్డ్ మ్యాచ్.
EMF.
Okay, it falls from January 15th onwards, January 22nd నుంచి starting. Okay, so again we'll be back from the third cricket match onwards. Again, Rohit Sharma will be back. Some people, they are interested towards the cricket. No one will say that what are the news or follow the news of the cricket. Some people, they are interested towards the automobiles. వాళ్ళకి ఏంటంటే వాళ్ళ ఫాదర్ కానీ లేకపోతే వాళ్ళు ఎవరు చెప్పరు కార్ గురించి తెలుసుకుంటుంటారు, ఇంజిన్ గురించి అని ఏంటి అని. ఓకే, దాన్ని మనం ఏమంటాం, వితౌట్ సప్లై ఆఫ్ ఎనీ ఎనర్జీ, ఓకే, దే ఆర్ గెటింగ్ ద నాలెడ్జ్ ఆఫ్ their interest, that can be called spontaneous process. ఓకే, ఇప్పుడు ఏదైనా చదువు ఉందనుకో, ఓకే, ఎవరైనా పెద్దవాళ్ళు చెప్తేనే చదువుతారు, అట్లాంటి దాన్ని స్టిమ్యులేటెడ్ అంటారు. So here also emission will be two types, stimulated emission and spontaneous emission. So for radioactivity, we are having the two types of process. Okay, that is natural, that is without supply of any energy. Okay, now see here, near to this radioactive element, I am keeping an, suppose, let us consider that, okay, let us consider that it is positive plate and here it is negative plate, or else I'll draw short like this. In this radioactive plate, what will happens, okay, towards the, that is, in the radioactive element we'll have electrons, protons and neutrons. Okay, so that means whenever the radioactive element is decayed, okay, some radiations will be attracted towards the positive plate and some radiations may deflected or attracted towards the negative plate. Okay, some may go undeviated, okay, fine. Now here it is that we can say the radiation which is attracted or which is deflected towards the negative plate can be called as alpha decay, and which is deflected towards the positive plate can be called as beta decay, which is undeflected can be called as gamma decay. Okay, why alpha particles will decay to negative plate, I will tell. Okay, why it will be, means I will tell. That is, in the alpha decay, what we are having that, suppose I am having an element having an atomic number as Z and mass number as A. Whenever it is radiated without supply of energy, then there will be a change in the mass. That is, atomic number decreases by 2 units, mass number decreases by 4 units. Okay, with the release of alpha particle. See here, since alpha particle is released, that means that alpha, it is containing 2 electrons. Okay, fine. And we are discussing about the nucleons, that is 2 protons are there. So protons will be deflected towards this one, negative plate. Okay, this is for the reaction for the alpha decay. Okay, all of you keep the side heading as radioactivity. Radioactivity. First point write down. First point write down. Okay, first point write down as spontaneous decay of naturally occurring naturally occurring naturally occurring unstable nuclei by emission of by emission of certain subparticles. Certain subparticles. Okay. Certain subparticles. Completed.
Yes, sir.
Inside brackets write down like alpha, beta, and gamma radiation. Like alpha, beta, and gamma radiation is called as natural radioactivity or spontaneous radioactivity. Okay, completed. అమ్మా అయిపోయిందా?
Yes, sir.
Completed. Next point write down. Next point. The radioactive nucleus. The radioactive nucleus before decay is called as parent nucleus. Parent nucleus. The nucleus resulting from its decay by particles can be called as daughter nuclei. Okay. Example, X gives Y plus R plus Q. X can be called as parent nucleus. Y can be called as daughter nuclei or daughter nucleus. R can be called as radiation. Q can be called as energy. Okay, write down this one. Okay, completed. అయిపోయిందమ్మా?
Yes, sir. Completed.
ఇది అయిపోయింది. నెక్స్ట్, కీప్ ద సైడ్ రేటింగ్ యాజ్ ఆల్ఫా డికే. Write down the reaction as MZA gives Z minus 2. Okay, suppose let us consider it as X A minus 4. Because atomic number decreases by 2 units means the nucleus will be changes plus He24. Okay, fine. Let us consider example, radium 88-226 gives Rn 86-222 plus He24 plus 4.87 MeV. Here plus means that it is energy is absorbed. Okay, completed.
Completed, sir.
Now, next, keep the side rating as beta decay. Beta decay. Okay. Beta decay. Okay. Okay, write on the reaction. MZA gives suppose X Z plus 1 A plus minus 1 E0. Okay, example, it is thorium 9234 gives palladium, PM is palladium 91 234 plus minus 1 E0. Okay, over. Completed.
Completed, sir.
Next, in this beta decay, we are having two types: beta positive decay and beta negative decay. Okay, in the beta negative decay, it is same as like beta decay. That is, atomic number will be increases by 1 unit and with the release of an electron and some energy E. Okay, and here we are having a subatomic particles. We are having a subatomic particles. Okay, I'll call them new. Okay, and here it is beta positive decay means, okay, atomic number decreases by 1 unit. Some XA plus, okay, see everywhere here the total atomic number, it is balanced in every reaction, you can see. Okay, even here also the total atomic number in the left hand side is equal to total atomic number in the right hand side, and even the total mass number in the left hand side is equal to total mass number in the right hand side, right? Okay, fine. Now it is, in order to balance here plus 1, this must be 0. Okay, that is particle which is having the positive charge and mass number is 0. That is, it will be proton. Okay, okay, this I can say that it is positive electron, or we can call it an positron. Positive electron can be called as positron. Okay, plus some energy and still subatomic particles. This nu can be called as neutrino, and nu bar can be called as antineutrino. Neutrino and antineutrino are both are conjugate particles. Conjugate particle means I can say proton is the conjugate particle to the electron. That is, both electron and proton are having the, with respect to magnitude, it is equal, but with respect to sign, they are opposite in nature. So these type of particles can be called as conjugate particles. That is, the particles which are having the opposite charges can be called as conjugate particles. Okay, remember the beta positive decay and beta negative decay reactions. All of you write down. Okay. Sometimes in IPE, they asked for 2 mark question. Okay. Till now, in the NEET, they asked direct question. Which of the following is the reaction for beta positive decay or beta negative decay? Like that they asked. Okay. Like that they asked. So, like that they asked. Okay. That's why please remember approximately, okay, from last 3 years, even in the JEE mains paper also, 2 to 3 questions, they are asking direct questions. See, in the last session, in the September session, they are asked for the formula for quality factor in AC, alternating current. They asked the formula for the quality factor. So please, all of you, even though you are preparing JEE mains, JEE mains is not that much standard or like that. You must be thorough with your fundamental. Each and every point you must remember. Don't think that every question will be application based. Okay, that is. So till now completed up to here. Completed.
Yes, sir.
Completed. Next one. See, till now we are discussing about the spontaneous decay or natural decay, natural radioactivity. Okay. Okay, fine. Suppose if you supply energy, then if you have the radiations, then it can be called as artificial radioactivity or stimulated radioactivity. Okay. Generally, in our textbooks, they will write it as natural radioactivity and artificial radioactivity. Okay. Artificial radioactivity means with the supply of energy, the radioactive nucleus, okay, divides into the daughter nuclei with the emission of alpha decay and beta decay. Gamma decay, it means that there is no change in the parent nucleus. Only energy will be lost. Okay. In the parent nuclei, whatever will be there, and the same thing will have in the daughter nuclei also. Okay. The same thing we are having in the daughter nuclei also. Okay. Okay, fine. Alpha. Okay. Next one, it is decay law. Decay law. One of the most important derivation. Okay. All of you listen carefully. Again, tomorrow also I will repeat this one. Again, tomorrow also I'll repeat this one. One of the most easy part. We are having the radioactive substance. Here you can see. Let us consider initially at time t equal to 0. I am having the number of nucleons as N0. Initially, I am having N0 nucleons are there. Okay. Now, here I am observing that as the time increases, number of nucleons will be emitted out. Okay. Let us consider N0 is the initial number of nucleons. Initial number of nucleons at time t equal to 0. Okay. Now, as time increases, what will happen? Nucleons will be emitted. Antena? Srihita, Shravyasri, Bhargavi, Ritu Reddy. Antena? So, I am considering n as number of nucleons emitted. Number of nucleons emitted. అంటే ఎన్ని నెంబర్ ఆఫ్ న్యూక్లియన్స్ బయటికి వెళ్ళినాయో చూస్తాను. ఓకే, సపోజ్ లెటస్ కన్సిడర్ మీరు ఎప్పుడైనా చూడండి, ఓకే, మన క్లాస్ అనే కాదు ఏ క్లాస్ అయినా ఇనీషియల్గా క్లాస్ స్టార్ట్ అయినాక ఏమవుతుంది, ఒక 50 మంది ఉన్నారు అనుకుందాం ఫర్ ఎగ్జాంపుల్. ఎట్ ద ఎండ్ ఆఫ్ ద క్లాస్ బిఫోర్ 5 minutes ఆర్ బిఫోర్ 10 minutes అంటే 8:50 లేకపోతే 8:40 అప్పుడు చూడండి. ఓకే, అంటే నేను ఇవాళ చూశాను కాబట్టి నాకు గుర్తుంది. స్టార్టింగ్ క్లాస్లో 50 ఉన్నారు. ఓకే, ఇప్పుడు ఆల్మోస్ట్ 8:50 అవుతుంది. 4 స్టూడెంట్స్ అనే దగ్గర. సో నెంబర్ ఆఫ్ న్యూక్లియన్స్ ఎమిటెడ్ ఈజ్ ఈక్వల్ టు 4 బికాస్ ఆఫ్ ఎనీ రీజన్. అది ఏ రీజన్ అన్నవచ్చు, ఇంటర్నెట్ అన్నవచ్చు, లేకపోతే ఇంకోటి అన్నవచ్చు. ఓకే, బికాస్ ఆఫ్ ఎనీ రీజన్ నెంబర్ ఆఫ్ స్టూడెంట్స్ ఎమిటెడ్ ఇట్ ఈస్ 4. So as time increases, this number of nucleons will be increases, emitted will be increases. So that means number of nucleons emitted it is n. Okay, suppose let us consider it is n1. N1 is the number of nucleons emitted. Okay, so then what will be number of nucleons remaining in the nucleus? N0 is the initial number of nucleons. N1 is the number of nucleons emitted. Then what will be the number of nucleons remaining in the nucleus?
N0 minus N1.
N0 minus N1. అంతేనా? దాన్ని మనం ఏమనుకుంటున్నాం, N అనుకుంటున్నాం. So as number of nucleons emitted increases, what will happens to N? ఈ N1 ఇంక్రీజ్ అవుతుంటే N వాల్యూ ఏమవుతుంది? Decreases. Always N0 it is constant. We are not changing N0. So that means there is a, with respect to time, there is a change in number of nucleons. So minus, since the number of nucleons are varying with respect to this one time. So since there is a decrease, so that's why I kept minus, is proportional to initial number of nucleons. Okay, in order to remove the proportionality, I am keeping a constant, lambda times n. Lambda times n. This can be called as decay law. That is, rate of change of number of nucleons remaining in the radioactive substance or radioactive nuclei is depends upon the initial number of nucleons. So upon rearranging, minus dn by n equal to lambda dt or dn by n equal to minus lambda dt. In order to find the number of nucleons remaining in the radioactive nuclei after a time t. At a time t తర్వాత ఎన్ని నెంబర్ ఆఫ్ nucleons ఉన్నాయో కావాలి. Okay, so we are integrating it. Okay, integrating it. At a time t equal to 0, we are having number of nucleons as n0. At a time t, we are having the number of nucleons as n. Okay, integral dx by x. What is the formula for integral dx by x?
log x.
ln x. Okay, మీరు log అని చెప్పేటప్పుడు log x to the base c. Okay, so this one I can write it as ln n between the values n0 to n is equal to minus lambda times t between the values 0 to t. So ln n minus ln n0 is equal to, apply the limits, minus lambda t. Log m minus log n, I can write as log m by n. Okay. I will write this one as in the form of exponential form. Can I write n by n naught equal to e power minus lambda t? So n is equal to n naught e power minus lambda t. As the time increases, number of nucleons remaining in the nucleus will be decreases. Till here, remember. Tomorrow, once again, we'll start from the decay law from here. Okay, from here. I think up to beta positive and beta negative decay you wrote.
Yes, sir.
Okay. Okay, fine. 9 o'clock మీ క్లాస్ ఉందా? శ్రావ్యశ్రీ, ఉషశ్రీ
Yes, sir. ఉంది.
9కి ఉందా? ఓకే ఫైన్. ఈ ఫొటోస్ మేడంకి పెడతాను, లేదంటే మీకు రేపు మళ్ళీ ఇక్కడి నుంచి డిస్కస్ చేస్తాను. డికేలా నుంచి రేపు రాసుకోవచ్చు మీరు. ఇంకా 8 minutes ఉన్నట్టు కదా. ఓకే, అందుకని ఈ డెరివేషన్ అంతా కూడా మీరు రేపు రాసుకోవచ్చు, లేకపోతే ఫోటో ఇప్పుడు పెట్టేస్తా, మేడంకి పెట్టేస్తా నేను. ఓకే, మేడంని అడగండి ఒకసారి.